Hello and welcome to Awesome Day 2024. My name is Peter and I have the pleasure of being your AWS technical trainer for this next session, Innovation with AWS. When it comes to innovation, it's about putting tools and technology together in a different way to help solve a specific problem. And just like if you were building a house, you not only want to know what tools are available, but you'd also want to understand the purpose for these tools, so you can make the best decision when it comes to building that home. It's the same thing with technology. We need to understand what's available to us and for what purpose it exists, so we can best utilize those tools to innovate. To start us off, we'll talk about 5 different topics in this module: Internet of Things, or IoT, machine learning, blockchain, AWS ground station, and AWS wavelength. First up is IoT, the Internet of Things. Now, things is a pretty broad word, and that's because IoT encompasses every device that can connect to a network like the Internet. Think about all the devices in and around your home that can connect to a network. Before it was just our computers, but now it's our lights, our watches, our cars, even our toasters and refrigerators, and so much more. IoT is where we collect and capture all the information coming from those different devices and use it to inform and automate different processes. For example, we might have a light sensor outside that detects the sunrise, which then automates raising the blinds in our home and starting that coffee machine so we can kick off our day. As the number of devices that we use and integrate grows, it also means that there are more devices we need to manage, which presents interesting challenges, especially because some of those devices we may not have physical access to. And a lot of times these devices don't have enough computing power to analyze the massive amount of information they're collecting in a meaningful way. So we need to send that information somewhere so it can be analyzed, which means we now need to consider data security, data privacy, and how we can store massive amounts of data coming from many different devices. This can be intimidating. To help us out, AWS has lots of different services available when building out your IoT solution. Here's a video to give us an overview of IoT on AWS.
AWS IoT isn't just about connected devices. It's about operating those devices at the edge, securely and at scale. It's about translating data into business value.
Using AWS IoT, we can get seed data to analysts in minutes versus days, which supports our innovations in precision agriculture.
For us, security is priority 0. It underscores everything we do.
We chose AWS IoT because of its leading-edge security capabilities. Policy-based security is a huge advantage of AWS. We don't know how we would have done it on our own.
Our global platform enables your IoT solutions to scale easily with edge-to-cloud reliability and low latency.
We chose AWS not only because of their technology, but for their ability to scale. AWS methodologies and culture have accelerated our implementation speed.
With AWS IoT services and the broadest set of IoT partners, we deliver deep domain expertise for edge-to-cloud solutions.
AWS's IoT offering is the most complete on the market, helping our team to rapidly build and deploy with the most cutting-edge IoT technology while developing deep relationships with our customers.
At AWS, we transform your IoT infrastructure so that you can focus on innovating for your customers.
One of the IoT services AWS offers is AWS IoT Core. AWS IoT Core is engineered so that you can connect billions of devices that send out trillions of messages securely to AWS services without you needing to manage the infrastructure to support that kind of scale, which means you can use it for small, medium, and extremely large projects. AWS IoT Greengrass is another service that can enable devices to act locally on the data they generate while still using the cloud for other features like analytics and data storage. IoT Greengrass allows us to run AWS Lambda functions on our IoT devices for local data processing. It can help us manage deploying our code across these different devices. And other features like devices being able to communicate on a local network instead of over the internet, such as your home network through your Wi-Fi router. All of this is already coded into pre-built components that you can just deploy without writing that code yourself. Here's how one of our customers is using AWS IoT Greengrass in the real world. ST Engineering is an organization that has robots as a service as a business offering. The company wanted to migrate its infrastructure to the cloud so that it could achieve scalability and develop a cloud-based fleet management system for its robotic fleets. They decided to adopt AWS IoT Greengrass so that these robotic fleets could connect with the cloud. It also allowed the robots to analyze their data closer to where it was being generated so that they could react autonomously to local events. And it allowed them to communicate with each other and other devices on the network securely. Now that we understand IoT a little better, let's talk about machine learning. Artificial intelligence, or AI, is a pretty broad category of different systems and techniques that try to mimic human intelligence. Machine learning is one of these techniques. It analyzes massive amounts of information to identify patterns, which it then uses to automatically build logical models. Now, there's many different ways to identify these patterns and build these logic models. One technique that's gaining a lot of momentum is called deep learning, which has allowed us to advance in areas such as speech and image recognition. You may have already heard of Gen AI or generative AI, which is a subset of deep learning that can be used to create new content such as text, images, audio, and much more. Let's take a look at a demo for getting started with generative AI on AWS. Recently, AWS launched Amazon Bedrock, which is a service that helps us build generative AI-powered applications using different foundational models. PartyRock is powered by Amazon Bedrock and is a code-free app building playground. If you're just getting started with generative AI, it's going to help you learn the fundamentals of prompt engineering and explore the capabilities of this new technology. Let's check it out by creating our first Gen AI application. We're going to create an app that generates inspirational text and images based on someone's mood. Now that we have the prompt in there, we can simply click Generate App. But to save time, I've already pre-created this application for us. I've named it Moodspirational. We can see that our application includes a field where a user can input their current mood, and based on that, we'll get some inspirational text and an image. Let's say that we are feeling lazy today. So once I put that in, PartyRock is using one of the foundational models to generate our text. Once the text is generated, in this case, make progress through small steps, it then uses that text to generate our inspirational image. Ah, pretty good. Another great feature of PartyRock is that we can make our application public so that others can use it. Simply click Make Public and Share, and that's going to generate a link that we can share out so that anyone on the internet can use our application. Just like this. Very cool. Hopefully this inspires you and gets those innovative juices flowing. Coming back one level up to machine learning. Machine learning can be used in all kinds of different ways to help innovate. Here's some examples of how we've used machine learning at Amazon. It helps us provide personal recommendations for our customers. It allows us to manage the scale at which we need to ship out packages every day. We've used it in our customers' products such as Alexa, and we are continuing to use it to help innovate different parts of the business. There's lots of different AI and machine learning services in AWS. We tend to categorize these in 3 different layers. The top layer, AI services, are services that can be implemented with very little experience. Services like Personalize, which provides recommendations for industries such as retail, media, and entertainment. Kendra, which allows users to search using natural language processing, like, what's a good dish I could make for the holidays? Polly is a service that transforms text to audio, and many more. The middle layer is for individuals who want to build or leverage machine learning models directly for whatever use case they can think of. And then at the bottom layer, this one is for those who want to work with the frameworks and manage the infrastructure for their AI solutions themselves. Amazon SageMaker was in the middle layer of the AI ML stack that we just saw. It brings together a broad set of tools that allows you to build, train, and deploy machine learning models at scale. It also offers access to hundreds of pre-trained models that you can deploy as well. Here's another video to explain.
Machine learning has become synonymous with innovation because business, societal, and environmental problems that were previously unsolvable with software, analytics, and big data can now be solved with ML-based practices. But real change can only happen if the reach of machine learning is democratized and the development of machine learning models is industrialized. Amazon SageMaker allows not only data scientists and developers, but also business and data analysts, regardless of their ML expertise, to build, train, and deploy machine learning models. Builders can use their choice of integrated development environments, or IDEs, low-code tools, and no-code interfaces that best suit their individual skill sets. SageMaker makes it easy to prepare massive amounts of structured and unstructured data for training accurate models. It also provides optimized infrastructure and purpose-built tools to automate and standardize MLOps processes to build, train, deploy, and manage models at the scale of hundreds of thousands or even millions. Accelerate machine learning innovation today by getting started with Amazon SageMaker.
Amazon SageMaker is actually used by Formula One. They use it to help analyze different race strategies and predict the outcomes for their teams, cars, and drivers. By using real-time data during a Grand Prix, it can also deliver rich and engaging fan experiences through different insights. Let's demo some more AI services just to show some different capabilities. We have a scenario where we have handwritten notes that we'd like to transform into audio. There's 2 AWS AI services that we can use to accomplish this use case. First is Amazon Textract. This service can automatically extract text and data from any document, including images. Let's try it out. I've already created an image of our handwritten note. Let's upload it to TextTract by clicking Choose Document and then selecting the image file. Now that our image is uploaded, we need to choose the data output type. We're just going to go with a simple layout. We have our results. Here's our handwritten note, now in text. Very cool. Now we want our text to become audio. To do that, we can use another AWS service named Polly. Polly takes text and creates lifelike speech audio files. Sounds like it fits our use case perfectly. We're going to copy our text from TextTract and paste it into Polly. Finally, let's give it a listen.
AWS AI services can really open up your imagination for what's possible.
Congratulations, we did it! We went from a handwritten note to a digital audio in just a couple of steps. Let's talk about blockchain next. When people hear the term blockchain, they tend to associate it with cryptocurrency. But blockchain technology can be used for so much more than that one use case. Blockchains allow us to decentralize trust, which means that they are great for situations where there's no central authority. A blockchain is just a series of transactions in chronological order whose history is immutable, meaning cannot be changed. Those ordered transactions make up a ledger. Each member of the network keeps their own copy of the ledger, and when a new transaction comes through, those members must agree that it's valid. If it is valid, and a new block is added to the chain. Here's a video to help explain it in a different way.
A blockchain is a distributed ledger that is decentralized, distributed, and immutable, enabling automated process workflows. Let's look at an example that demonstrates how this technology works by visiting the voting process. Traditionally, people go to a trusted location to cast their vote. They mark their ballots, which are submitted through a centralized, trusted party. It's a system that's been developed over a long period of time. But what if, instead of mailing a ballot or visiting a voting booth, you vote using a private digital voting token that's linked to your identification when you register to vote? With a distributed ledger, voter registration, verification, collection, and tallying can be automated. And it's trusted by everyone because identities are protected with digital signatures. The ledger is shared across multiple parties, and any changes made must be agreed upon by all. Participants can see the history of the immutable ledger, replacing the traditional previous need for a trusted third party. This is just one example of how blockchain technology can transform a common process. So how can building a blockchain on AWS be beneficial? You can build a superior blockchain solution by using AWS APIs and service integrations. Just like with a database, you can use the wide range of AWS capabilities to perform various functions on a blockchain. For example, technically savvy voters could incorporate AWS analytics services to gain insights to what is taking place on a blockchain. They could also create live streaming visualizations of how each group is voting across a geographic area. Give your blockchain superpowers with AWS.
Let's talk about some more use cases where having a distributed immutable ledger would be beneficial. In shipping and supply chain management, it could be used to track the movement of goods between suppliers and buyers. The retail industry could use it to verify that all goods sold on the platform are authentic. Media and entertainment could use it to manage and verify copyrights. Advertisers could use it for custom loyalty programs. Finance could use it to manage online transactions, accounts, and cross-border payments. And that's just scratching the surface. We've just talked about some cases where utilizing a blockchain and its ability to decentralize trust can be very useful. But what other benefits does this decentralized trust model bring? First is transparency. Because every member of the network keeps a copy of the ledger, they have full visibility into what transactions have occurred. The historical transactions on the blockchain cannot be changed, meaning they are immutable or permanent in nature. This allows everyone to be confident when they audit those transactions on the blockchain. With decentralized trust, the members of the network need to come into agreement every time there is a new transaction. There's a lot of different ways for members to agree, which is one of the reasons there are several different types of blockchains out there. In order for you to reap those benefits, you need to set up a blockchain for your use case. However, this can be a bit complex. Each member of your network will need their own compute, the correct software installed, certificates to manage trust and access control, and networking configured, so all members can securely communicate. Sounds a little daunting, doesn't it? The good news is AWS has blockchain services that can help. One service is Amazon Managed Blockchain. This service is designed to help you build applications on both public and private blockchains. Private blockchains are those where you can control who becomes a member of your network. Public blockchains are free for anyone to join. AWS Managed Blockchain is a fully managed service, meaning AWS will create and look after a lot of the infrastructure for you. And just like other AWS services you've learned about today, you're only paying for the resources that you're using. It supports multiple different open source frameworks and is backed by Amazon's Quantum Ledger database technology, which means it's going to be able to scale to meet your needs. Now here's another real-world use case from one of our customers. Part of Korean Air's business was to handle the transportation of COVID-19 vaccines. When transporting vaccines, the container must maintain a certain temperature. If not, those vaccines would need to be discarded. So Korean Air needed a way to be able to report periodic temperature checks from different containers that was transparent, immutable, and auditable. Blockchain technology is perfectly suited to this use case. So they used Amazon Managed Blockchain. Now, let's switch gears and discuss AWS Ground Station. AWS Ground Station is a service that allows us to utilize data coming from satellites. Satellites are used for a wide variety of use cases, including weather forecasting, surface imaging, communications, and video broadcasts. Today, more and more satellites are being sent into orbit for these different use cases. Some of these satellites are public, meaning anyone can access their data, like the Aqua satellite sent up by NASA, which collects information on the Earth's water cycle. Other satellites are private because they are launched by private organizations. Once the satellite is in orbit, the information it's broadcasting back to Earth needs to be collected. To do this, you need physical infrastructure on the ground, like antennas, compute, and storage to receive that data, which can be expensive. This is where the AWS Ground Station service can help. Let's check out a video that gives us an overview.
Thousands of active satellites are currently in orbit, collecting massive amounts of data. Businesses, universities, and governments use this data for a variety of important applications. But to transmit and receive this data, you need access to antennas. And to process, store, and transport data, you need compute and network infrastructure. You need to build business logic, scripts, and workflows to make it useful. And then you have to migrate it all to the cloud for processing, analytics, and machine learning. This all requires significant capital investments. Instead, you can simplify complexity and cost with AWS Ground Station, a fully managed service that lets you control satellite communications, process data, and scale your operations. Since it's pay-as-you-go pricing with no minimum fees or long-term contracts, you don't have to worry about building or managing infrastructure. AWS ground stations are located near AWS infrastructure regions around the world, providing low-latency access to AWS services. This reduces data processing and analysis times for use cases like weather forecasting, surface imaging, and communications from hours to seconds. Rely on the AWS platform with the most functionality, agility, security, and performance to test, run, and analyze your satellite operations. Quickly integrate data with your applications running in the AWS cloud, like Amazon SageMaker and Amazon EC2. AWS Ground Station's global footprint helps you access satellite data when and where you need it. Use this data to build your applications and succeed in your missions on Earth and in space. Visit aws.amazon.com/groundstation for more information.
As you just saw, AWS Ground Station is a fully managed service that lets you scale your satellite operations quickly, easily, and cost-effectively, without having to worry about building or managing your own ground station infrastructure. AWS Ground Station delivers global ground station as a service. It provides direct access from ground station to other AWS services and the AWS global infrastructure, including our low-latency fiber network. There's no commitments or licensing requirements, and it uses that pay-as-you-go pricing model we've talked about with other services. Capella's space needed to provide access to satellite data within minutes of its capture, which is far faster than traditional satellite data delivery services. By leveraging AWS ground stations antennas located around the world, Capella's Earth observation solution is able to deliver satellite data to customers more cost-effectively than ever before, to help their customers in areas such as agriculture, infrastructure, defense, and disaster response. Finally, let's now discuss AWS Wavelength. More and more devices are connecting to the internet through a mobile network. With the creation and adaptation of 5G, we're able to stream more data faster over that network than ever before. And the use of these 5G networks is growing. It's forecasted over the next 4 years that close to 2 billion mobile subscribers will be using 5G. We can use these connections to access our applications running in the cloud. Some of these applications will need ultra-low latency. However, our mobile devices, which connect to a 5G tower, which then connects to the internet, which in turn connects to our AWS infrastructure, may not be fast enough. To speed this up, we need to move AWS infrastructure to the communication service providers' data centers, where the 5G connection is established. That's what the AWS Wavelength service does. Wavelength deploys AWS compute and storage services to the edge of the telecommunication carrier's 5G network. By moving those resources closer to the 5G antenna connection, we enable ultra-low latency data processing from mobile devices. Because this infrastructure is still managed and supported by AWS, you interact with AWS resources running in a wavelength zone like any other AWS service. Here's a video to help us understand.
Whether you need to deploy your application workloads across the globe in a single click, or you want to build and deploy applications closer to your end users, AWS provides you the cloud infrastructure where and when you need it. As 5G networks are rolled out across the globe, enterprises and application developers will rely on its advancements in bandwidth and latency to deliver solutions like immersive gaming experiences, smart cities, robotic manufacturing processes, improved autonomous driving, and more. AWS Wavelength brings AWS services to the edge of the 5G network because wavelength zones are infrastructure deployments embedded within data centers at the edge of the 5G networks. Application traffic from mobile end users can reach servers running in wavelength zones without leaving the communications service provider's network. Wavelength zones effectively reduce the extra network hops to an AWS region that can result in latencies of tens of milliseconds or more, allowing customers to take full advantage of 5G capabilities. Wavelength zones enable use of the same AWS infrastructure, services, APIs, and toolsets that you're already familiar with in the cloud. Applications running in wavelength zones have fast, secure, and seamless access to the full breadth of services in the parent region. And Wavelength offers all the familiar AWS benefits like elasticity, availability, and pay-as-you-go pricing. Deploying your application to run on AWS Wavelength is easy. Include the desired wavelength zones into your virtual private cloud on AWS and launch infrastructure resources in the wavelength zone as per your application requirements. Configure your network to access these resources directly from the mobile network. In just a few short steps, you can deploy portions of your application that need ultra-low latency in a wavelength zone. Together, AWS and communications service providers are ushering in an era of interactive applications and immersive experiences built on a 5G edge cloud.
Now that we can have ultra-low latency data processing from a mobile connection, it opens up a lot of new use cases, especially for AI and machine learning applications. The healthcare industry can use it for analyzing real-time data for diagnosis. The automotive industry can use it to help make our cars smarter, such as autonomous driving and warning about road hazards. Manufacturing can use it to better process information and coordinate all their devices in and around their factory. Wua Brothers developed DiliDrive, which was a robotic delivery service for short-distance delivery. After testing, they realized that controlling robots in an outdoor environment presented a significantly higher technical barrier than controlling them indoors. There were lots of additional variables that needed to be accounted for, like severe weather, different road conditions, and unexpected encounters. They realized they needed a remote management system for safe driving. However, the 4G LTE network couldn't meet their ultra-low latency requirements, so they decided to test out 5G and AWS Wavelength. The increase in data bandwidth, faster speeds, and edge computing allows their robots to register surrounding environment information in near real time for a safer robot delivery service. I hope you've enjoyed this session and found it interesting. We would love to hear what you thought about this session. Please take a minute to complete the survey. Your feedback is important to us and can really help shape and improve events and learning in the future. You can also reach out to us on the various social sites listed on this slide. And why not test your knowledge? Make sure you complete the knowledge check after this session to see how you're progressing. That's the end of this module. Next up, join me for Module 5 to find out how you can put it all together and start building on AWS. Thank you.